Hello, my dear student. Today I am going to discuss about Edexcel IGCSE O-level physics chapter sound wave. In this chapter, we have to learn about why sound wave is a longitudinal wave. Know that sound waves are longitudinal waves which can be reflected and refracted. Know that frequency range for human range 20 to 20 hertz, 20,000 hertz. Practical investigate the speed of the sound in air. Understand how an oscilloscope and microphone can be used to display a sound wave. Practical, investigate the frequency of a sound wave using an oscilloscope. Understand how the pitch of the sound relates the frequency of vibration of the sound source. Understand how the loudness of the sound related with amplitude of the vibration of the sound source. First, specification point 3.23, know that sound are longitudinal waves. So sound is a form of energy which gives us the sensation of hearing. By the help of sound, we can hear sound wave, we can hear anything. So sound wave is a longitudinal wave. What is longitudinal wave? If the direction of vibration of the medium particles are parallel or same direction to the direction of propagation of the wave is known as longitudinal wave. When sound wave travel through air medium, then molecules of the air moves to and fro like this. So the direction of vibration of the medium particle, vibration of the medium particle, and direction of propagation of the wave. So movement of the wave or propagation of the wave, propagation of wave. If the direction of propagation of the wave is parallel or same direction to the direction of vibration of the medium particles, here direction of vibration of the medium particle is to and fro. That means sometimes molecules comes closer and sometimes go far away. So compression and rarefaction, and wave propagate horizontally. That means same direction or with angle 0 degree. Then that type of wave is known as longitudinal wave. So sound is a longitudinal wave. So what is longitudinal wave? If the direction of vibration of the medium particle is parallel, remember parallel to the direction of propagation of the wave. That means angle between them is 0 degree. Then that type of wave is known as longitudinal wave. Sound wave is a longitudinal wave. Another types of wave are there, is known as transverse wave. Light is a transverse wave. Here, what is transverse wave? If the direction of vibration of the medium particle is perpendicular or 90 degree to the direction of propagation of the wave is known as transverse wave. But sound wave is a longitudinal wave. So sound waves consist of vibrating air molecules. They are types of longitudinal wave. So look at the diagram, longitudinal. The direction of vibration of the medium particle is compression and rarefaction, and direction of the sound energy is horizontal or parallel or same direction to the direction of vibration of the medium particle. Sound waves are longitudinal. The molecules vibrate in the same direction as the energy transfer. So as with all the waves, sound waves can be reflected or refracted. The reflection of the sound wave is called echo. So reflected sound is known as echo. So we know the frequency range for human hearing is 20 hertz to 20,000 hertz. So human ear can hear only the sound with frequency 20 hertz to 20,000 hertz. So human ear cannot recognize the below the 20 hertz and above the 20 hertz. That's why this range is known as audible range of the human brain or human ear. So as the frequency of the sound wave increases, the pitch of the sound also increases. Human can hear sound between 20 hertz and 20,000 hertz in range. So although this range decreases with age. Okay, sound wave is produced from a vibrating object. When any object vibrate, then it produces sound. So sound is produced from a vibrating object. Sound is produced from a vibrating object. How sound are made? Sound are produced when matter vibrate. As an object vibrates, it gives energy to the particles of matter around it. Sound is a longitudinal wave, and it moves with a series of compression and rarefaction. Look at the diagram here. Sound is produced when the matter vibrates. As an object vibrates, it gives energy to the particles, matter around it, and sound is a longitudinal wave, and it moves with series of compression and rarefaction. What is compression? Compression is the region where the medium particles comes closer to each other, where pressure is higher. That region is known as compression. Another is rarefaction. Rarefaction means when the molecules goes far apart or move away from each other is known as rarefaction. In the rarefaction region, the pressure is lower. So look at the slide here. So sound is produced from a vibrating object. A sound wave consists of mechanical vibration in air and other substances. Sound is a longitudinal wave in which the wave energy travel in the same direction as the particle within the wave vibrate. So sound wave is a mechanical wave. Why it is mechanical wave? Mechanical means here required a physical medium. Mechanical means here required a physical medium for its propagation. That's why it is called mechanical wave. So the wave which required mechanical, that means physical medium for its propagation from one place to another place, is known as mechanical wave. Sound wave requires physical medium for its propagation. That's why sound wave is a mechanical wave. Sound wave cannot travel through vacuum. Sound wave cannot travel through free space. So sound wave needs a medium for its propagation. That's why sound wave is a mechanical wave. Look at the diagram here. Some reason the molecules comes closer to each other than usual is known as compression, and some reason the molecules goes far apart. So the air is through air, the sound wave consists of series of compression and rarefaction. A compression is a region of slightly higher pressure where the air molecules are closer than the usual. And rarefaction is the opposite. That means where the molecules goes far apart each other is known as rarefaction. So wavelength of the sound is equal to the distance between two center of the compression. Look at the board here. Say here is the molecules comes closer to each other, and here they are goes far apart each other. Then again comes closer each other, then again goes far apart each other, far apart each other. So the center between uh, two compression region, here it is compression, here it is compression region, it is compression region, and here it is rarefaction region. It is rarefaction region. Compression region is denoted by C here, and rarefaction region is denoted here by capital R. So center between two compression region is known as wavelength. This is the way to find out the wavelength for the sound wave. Sound wave. So the wavelength of the sound wave is equal to the distance between the center of two successive compression. So the wavelength, so the wavelength of the sound wave is equal to the distance between the center of two successive compression. Center of two successive compression. So the wavelength of the sound wave is the equal to the distance between two successive center of the two successive compression. Here is the center of the one compression, and successive another compression region center. So say the distance between center of the two successive compression is known as wavelength of the sound wave. Now range of hearing of the sound wave.